Yes, hello everyone. Thank you so much for joining us for today's session. It's Deo Gracious here, welcoming you for today's session. And I appreciate all those who are trying so hard. Very many people have now finished up the shear wall reinforcement modeling, and others are already into the beam detailing. Okay, that is a very good progress. And as Captain Gatimo said last time, that was during the previous class, about the shear wall. If you're getting so much stuck and it's it's making you lag behind, it's advisable to first concentrate on one wall. If you can produce one wall perfectly, yeah, you you model the reinforcement well, then you annotate it very well. That would be very good. It's very good progress. That is good enough for you to proceed to the next deliverable, and we continue like that. I encourage us to not give up and keep pushing on and pushing on and pushing on till the very end. Thank you so much, Captain Brian, for the opportunity.
Okay, you're welcome, Captain. Engineer Alan, are you with us? Maybe.
Hello, engineer. How do you do?
Hello, engineer. I'm doing great. Hope you too.
Okay, I'm also doing well. Engineer Alan had informed me that he might join later on. He's having some network issues and electricity issues, so he won't be with us as the meeting starts, but I'm sure he's going to join on later on. So I can take over. Thank you so much for hosting the session for us and for guiding us through the videos and also, giving us a brief overview of what you are going to cover today. So thank you so much, engineer.
Thank you.
So I will proceed. First, I hope you are all doing well. I have seen good progress in the deep cubes. I've seen more and more people submit their shear wall detailing and annotation. And as the gracious has said, if you're still stuck at that stage, just do one of them, and then you can go back and do the others later. And then after you do your shear walls, you can move on to the beams, and then you can now catch up with us. So for today, we are going to try and do something really simple. And what you're going to do is one, model the ribs for the staircase. And then two, we are going to model the rib beams as well as the hollow boards. So from the interaction, I have gauged that most of us have not been able to interact with the hollow board slab system. The hollow pot slab system works in a really similar way to the rib beams. We use them in long spanning slabs where we would want to increase the depth of the slab and also reduce its weight. Okay, so it allows you to model, to have slabs that span over longer distances. So if you have a solid slab spanning over 6-7 meters, you could prefer to change to the hollow pot slab system or the waffle slab system, just to be more economical with concrete and also to ensure that your design passes the design check. Not the design check, the deflection checks as you design. Okay. So with that, we are going to proceed to the software, and then we are going to start with modeling rebars for the staircase. Okay, so I'm going to share my screen, and once you can see my screen, please type a one so that I can know we are together. Please type a one if you can see my screen. Let me know that we are together. Okay, super. Thank you so much. So I'm going to go to modeling the staircase, to modeling the rebar for the staircase. So at this point, we have modeled rebars for most of the elements, and all that is remaining is the staircase and the slab. So for today, we're going to start with the staircase. And to model rebar for the staircase, we need to have to work in sections, just as we did earlier. Just as we have done for all the other elements, we need to work in sections. So for you to model any reinforcement in Revit, I hope by now you can at least appreciate that you have to do it in a section. Okay, so I will delete these sections that had already been created so that we can create new ones from scratch. Okay, so to model Riba for the staircase, first thing you have to do is to go to one of the structural plans. You can open any of them. So I'm going to open the first floor. And then once I open the first floor, I will have to create a section view. And then this is a tricky bit for stairs. You have to work with two sections. So the first section will allow you to model rebar for the first run of the staircase. And then the second one will allow you to model rebar for the other run. So one will allow you to model rebar for this run of the staircase, including the landing. And then the other view is going to allow you to model rebar for this other run. Okay, but don't worry about that. You are going to see it in action. So let's start. To create the section view, just as we did before, you go to view and then you click on section. You click on this drop down and you create a section. So if you do not have a staircase section, just select any of these, go to edit type and duplicate it. But if you have a staircase section, just left click on it and place your section. So place your section along the staircase. So ensure it views the other, it views the other run. So I want to place it along this run. Okay. So this is my first run. I will place this view running in this way so that the view depth, okay, so that this view depth goes into this run as well. Okay, so I want this staircase to show me this run of this. I want this view to show me this run of the staircase as well as this run of the staircase. And then for the second view, I'm going to do the same thing. I'm going to go to view, section, and then I'm going to create the other section. So for this other section, it's going to be oriented or facing the opposite direction to this one. Okay, so this one is facing this run, and then the view or the section view along this run is going to be facing this other run. So you're going to create that section view, and then to make it less cluttered, you just reduce its depth. And then after you do that, you can now go to your section views. Okay, let's look for the section views. Here they are. And you can open both of them. So open both of them and we'll proceed. So after you have opened these section views, you can change the scale. You can work with 1:50 or 1:75, depending on how much detail you need in your in your papers. So if you want to fit more details into your paper space, then you can work with a smaller scale, the 1:75. But if you're going to have a dedicated page for the staircase, you can use the 1:50 because it's going to allow you to have a bigger drawing or a bigger representation for your staircase details. And then after you do this, you're going to follow the same procedure that we have done over and over again at this point. We are going to clean this up a bit. So we're going to select the grids that we do not need in the views as well and hide them in view. Okay. So we're going to hide all the elements that we do not need. And we can also extend this forward just a little. Okay. And then after that, we can hide this in view, ensure that it's very clean. And then you are good to go. And then go to the annotate tab, use the components, and now place the breakline so that you can have your breakline there. So then select the breakline and copy it to the other floors. So copy it upwards, choose a base point that you can easily track or you can easily find in the other floors and place it. Okay, and then you have your break line there. And then let's copy it as well from this floor. to this floor as well. And then from here, we can extend it so that it goes below, below the ground floor. And then I'll select it, type CS to create similar. I'll select it, type CS to create similar, and then I'll create another one there just to break my columns. Okay. Then I can bring this one up a little bit and fit it much better. Okay. And then after I have that, I can just copy this to the other columns. Okay, so that's what you're going to do. And then after you've done that, you're going to have a very, very clean detail. So we are going to start with one thing. The first thing that you're going to do is to create the staircase thickener. And this thickener is what is going to be the foundation for our stairs. I remember in one of the sessions, someone asked about how we model or how we show the staircase foundation in the ground floor. Okay, so this is how you do it. We create a staircase thickener in Revit. And to do that, it's relatively easy. You go to the View tab, and then we use the cut profile. So we use the cut profile to create the staircase thickener, or what you'd call the staircase foundation. So that is the foundation that is going to be restraining or supporting this slab from this point here. Okay, so we are going to start with that. And before I create it, I could reiterate the process that we are going to follow to model rebar for the staircase. So the first thing that you're going to do is you're going to go to a structural plan, and then you're going to create two views. Okay, you're going to create two section views, and then you're going to ensure that these section views show you both runs of the staircase. So this one should show you should be placed along this run, and it should show you this run as well. And then this one, you should place it along this run, and you should extend the view depth so that you can view this other run as well. So if I was to select one of these views and then reduce the view depth so that it does not go into the other run, this is how the detail would look like. Okay, in the section view, you will not be able to see the other run. But as you extend it, remember, as we said earlier, there are the deeper or the more objects in your view in the view depth, the more you're going to see in your section. So after you extend it, you're now going to be able to see it in the other, in the section as well. Okay, so with that, I think we can proceed to model the thickener. So as I said earlier, working with sections for the staircase is a bit tricky, not difficult, just tricky. You have to know that the software will allow you to only interact with one part of the staircase in each view. So there is one section here that will only allow us to interact with the lower run of the staircase. And then in the other section, the software will only allow us to interact with the top part. Okay. So you don't have to worry about that. You can just continue with your modeling. And then once you get to that part and you find that you cannot select the other run, just close what you are doing and go to the other section. Okay, so let's do that. So let's create the cut profile. So if you click on cut profile and you come to your section and you try to select this lower run of the staircase, you're going to find that I cannot select it in this section 5. Okay, but if I go to section 4, I should be able to select it. Okay, I hope you saw that. So if you go to section 5, I'm only allowed to interact with the top part of this run or of this staircase. So if I try to create the thickener using this view, I will not be able. If I click on this run of the staircase, the software will not allow me to select it. Okay. So if you get yourself in a similar situation, just go to the other run and then clean this run up, and then clean up this section. So if you try to do something in one of the sections and the software does not let you do that, just click on escape, get out of that command, and then go to the other section. And then this is the section that you're going to be creating the cut profile. So if you go to the cut profile and select the lower run of the staircase, and it is highlighted in such a manner, this is a section that we are interested in. So this is the section that we have to clean up. So I'll clean my sections again. I'll hide the unnecessary items in this section. Okay. I'll hide the unnecessary items in this section, and then I'll just extend it a little bit. And then I'll go to annotate components and redo basically everything that we had done in the other view. Okay. So let me, for this one, start with these columns here. Let me have something of that sort and bring it up just a little bit. Okay, and then I'll select this and copy it from that grid to the other columns as well. Okay, and then with that, I can now bring this one up to that section. Then I'll change the scale to 1:50, and then I'll select one of these. One of these break lines, type CS to select create similar, and then I'll place another section or another break line at that point, and then I'll extend it and have it at that point. Okay, then I'll just select this, create similar, type CS to create similar, and place another one at that junction. And then I can minimize this one so that it fits better into this slab, because this slab is a bit, it's a bit thinner, or it has a lesser depth than the ground floor. So after I have that, I'll just select this and copy it to the other floors. Okay, I'll select this and copy this to the other floors. Okay, so that's how we do it. And then after you do that, please ensure you hide everything that you do not need, like like those section views, they are unnecessary at this point. So select them and hide them. All right. And then after you have such a clean detail, go to we want to start with creating the staircase foundation, or what is referred to as a staircase thickener. So what we do is we go to structure, or we go to view, and then we create that cut profile. So basically how the staircase foundation or thickener happens is remember that this slab is only 150 millimeters deep. And then we have these dust blinding, and then the compacted maram. So these materials are not strong enough to provide the staircase with any kind of restraint or support. So the thickener shows the guys on site that at this point here, this foundation will not, or this staircase thickener or foundation will not be formed of these materials, this compacted maram as well as the dust blinding. It's going to be concreted with a ground floor slab. Okay, so that's the purpose of having that thickener. So to model that thickener, or to model a representation of that thickener, we go to the view tab, and then we use the cut profile. And then in the cut profile, we have two ways of modeling the cut profile. So we have by face and boundary between faces. So for this one, since there is no, we use by face when there is no other material between those two faces. So for example, this one you're going to use face because there's no other material here. And then for the slab layers, we are going to use boundary between faces because there are multiple faces. We have this face, then we have this face that is the layer for the dust blinding, and then this face for the maram. So we say, as we said, we are going to start with cut profile, then ensure that in edit you have selected face, and then select the lower run of your staircase. Okay, and then after you do that, just draw a line and just extend your cursor downwards at the end of the second thread. Okay, extend it downwards, and then once you get to the boundary of this lower edge of the staircase, left click, drag it downwards, and then drag it to this other edge where where this lower surface of the staircase meets the ground floor. Okay. And then at this point, you have to note that you should not close this boundary. You have to leave one of the edges open. Okay. I repeat, you should not close this boundary. You need to leave one of the faces open. So this is the face that you are going to be leaving open. And then this arrow here shows you the material that is going to be used to create the thickener. So since we want the staircase material, the concrete to be used to create the thickener, this arrow should point inwards. So if your arrow points inwards, just click on finish. But if it points outward in this manner, just click on it and then it will face the other way and then click on finish. Okay. And then you have the first part of your thickener. So we're going to proceed to create the others. So to create the rest of the thickener, we are going to go to structure, not to structure, to view, sorry. And then we are going to be using the cut profile. So you left click on cut profile. And then for now, we are going to use boundary between faces. But before, okay, we are going to use boundary between faces. So I will left click on boundary between faces. And then I'm going to be prompted to select the face I want, right? So we are now interested in creating the thickener downwards here, okay, between the layers, between the slab layers. And that's why we said we use the cut profile boundary between faces. So you go to cut profile, you click on boundary between faces, and then you zoom in and select this boundary between the concrete and the dust blinding. Okay, so you select it, and then after you select it, the contextual ribbon is going to change to allow you to model. So before you model, we're just going to draw a few lines so that they can guide us. So I'm going to use the peak lines, and then I'm going to enter an offset of 150 mm, and I'll offset this by 150 on this edge, and this by 150. Okay, then I'll press escape, select this edge that I just drew, extend it downwards, select this one, and extend it downwards. And then after I do that, now I can make I can now model my cut profile. So I'll select line. I'll come to the intersection between this line and this boundary, this intersection, and then I'll draw an inclined line at 45 degrees. And then I'll do the same on this other end. I'll draw a line, and then at this point, it will be 135 degrees, okay? And then I will extend it to meet this line here. And then after that, I'll delete these other lines. They are not necessary. And after you have that, remember one face has to be open. So this is the face you're going to leave open, and you're going to click on finish. And you can see now that some profile has been made here. You can see now the concrete is going into this level at this point, and then at this point it goes back into the layers as they were. All right, so we have that there. So the next one is to create the boundary between this material here and this material here. So to do that, we go to cut profile, and then we select boundary between faces. And at this point, you're going to select this boundary, okay? And then after you select this boundary, it's going to go down by a depth of 150 mm. So you click on peak lines, and then in the offset, you enter 150 and press enter. And then after that, you just create your offset going downwards, all right? And then you use the line tool to just guide this one to go downwards. So extend it by 45 degrees and do the same on this other edge. So on this other end, just do 135 degrees. And then after they join, use the trim extend to corner to trim them. Okay, use the trim extend to corner to trim them. And then you can click on finish and you're good to go. And then by doing that, you've now created a detail for your staircase thickener. All right. So after you have done that, now you can start modeling your rebars. So it's going to follow the same procedure that we did for the other elements. The first thing that you are always going to do is to create, is to model the concrete cover. So you're going to start with the concrete cover. You're going to go to structure, and then we are going to left click on cover and select our staircase. And then after you select your staircase, we are going to create a new cover here. We are going to create a new cover setting for the slabs and staircase. So I'm going to click on add and add slabs and stairs. Okay, and then in the setting, I'm going to use a setting of 25 and then click on OK. And then I'll select my stairs again, click on this drop down and select the cover we just created and then click on escape. All right, so we have that. So now to model the other bars, to model the staircase bars, we are going to start with the starter bars. And the starter bars are the bars that go into the thickener and they are going to be restraining our our staircase from this point here. Okay, and then after that, we are going to model the bottom one bars and the top bars as well for the staircase. And then remember, as we said, Revit only allows us to interact with one run at a time. So in this section, we can only interact with the lower run. And then in the second section, we can only interact with the upper run. Okay, so you're going to go to section, left click on rebar, and then we are going to draw them by sketch. So click on sketch, and then as usual, you're going to select your staircase. So to use the sketch option, you go to rebar, you left click on sketch, and you select your staircase. And then after that, you can now model your rebar. So before we model our rebar, let's go to the properties. Ensure that you are using a diameter of T12 for the starter bars. And then for the partition, let's create a new one. Let's call it stairs, right? And then in the rebar set, we cannot change that at this point. So we are going to draw it first. We are going to draw the layout of our rebar, extend it to that point there. And then for this point, extend it to this point here and bring it upwards. And then at this point, this is going to be used to, is going to be used to restrain our slab, our staircase in that order. So you extend it to that point there and you use the trim extend to corner and you use it to join them. So if this happens, just redo that. And you have the outline for your, starter bars. Then after you have that, click on finish and you have one starter bar. Then select the starter bar, go to its properties, change the layout rule from single to maximum spacing and have a spacing of 200 mm. And then in the comments, now enter the new comment. We've not used this comment before, so it's going to be starter bars. And then you can click on apply and you are good to go. So that is the first step. Then the second step will now be to model the bottom one bars. We are going to start with modeling the bottom one bars. But before I model the bottom one bars, I'd like to bring something to your attention. So the bottom bar of the staircase usually goes into the top part of the landing as well as into the slab. So the bar that is going to be running along the bottom part of the staircase is going to go into the top part of the slab. All right, and the reason for that is if it goes to the top, it has a larger concrete depth to anchor it or to provide the restraint it needs. So you can imagine if this bottom bar, that is the main bar along this direction or along the longitudinal direction of this staircase goes into the bottom part of the landing, it means that it will only or the bottom part of the slab, it means that it will only have a concrete depth of about 25 mm or 30 mm to support it. But if it goes upwards, it has it has a deeper depth, or it has a larger depth to support the staircase. Okay, so with that, we are going to proceed. So we are going to start with the bottom bar. We are going to select rebar, and then we are going to go to sketch. And then after you go to sketch, we are going to select the staircase. At this point, I hope you can see what I was saying earlier. Revit allows you to only interact with the lower run. So in this run, you can only see, you can see only the lower run of the staircase has been highlighted through the entire structure. Okay, I hope you can note that. If you've taken note of that, please type a 1. I know it's really important. I don't want anyone to go try and model the river and then they get stuck. If you've taken note of that, please type a 1. Let me know that we are together. Okay, so I can see we are together. So after you've, okay, let me repeat that. So we want to model the bottom, the bottom spanning bars. So to do that, we go to rebar, and then we are going to select sketch. And then after you select sketch, the first thing that you're going to be prompted is to select the family that is going to be hosting the bar that you want to sketch. So you select the staircase. And then after that, you're going to notice that the view you are in will highlight the part of the staircase that you are allowed to interact. So for now, you can see that I'm only allowed to interact with the lower run of the staircase in this view. So if I wanted to model the pass for this upper run, it means I'd have to go to the other run. And then you don't have to cram or have to know which section is used to model the lower run or the upper run. Just do this trial and error. If you go to model something and it does not allow you to select, just go to the other view. Okay, so let's start. To model this bar, we are going to start from this point here. We are going to draw a line at this section there, and then just a small line there. And then at this point, we are going to draw another line along, along the cover. And then at this point, we are going to draw a line along the top edge of the cover. As we said, the bottom bar of the staircase goes into the top part of the slab, or the adjoining landing. Then after you have those three lines, use the trim extend to corner. So click on trim extend to corner, select this line as well, then select this line and select this line. Okay, so sometimes this happens. So just select this line and join this, and then use the trim extend to corner in the different direction, and then click on finish. And then after you have that, you can select this rebar, and then if you want to change the bar diameter, you can do it from here. So after you've selected the rebar, ensure the partition is correct. Stairs in the layout tool, click on this drop down and change it to maximum spacing. And then for the spacing, let's have 200 mm. And in the comments, we are going to have it as bottom 1 and click on apply. Okay, so we have that. Then the second one, the second thing that we need to do now is to model, the top bar for this portion over here. So to do that, we go to rebar. We are going to use the sketch, and then we are going to click on sketch and then select your stairs. Okay, so if you are not sure about the length of the bar that you should be drawing as your top bar, this length should be at least a third of your staircase span. So if you are not sure, you can just measure and then get to know what the length of this run is, and then have your top bar running along that direction. And then in the landing, it should go the same distance. So if you find that in this run, you need about 1.2 meters, go in this way. So for example, if you need about 1.2 meters or 960 meters going that way, so you have to ensure that in this run as well, it has to be at least the same. Okay, you have to ensure that it's at least the same. But for encourage, we just extend it to we extend it to the end of this landing. Okay, and then after you have that, you click on this trim extend to corner and you join them. Okay, so that did not go how I wanted. I'll just draw another line here, and extend this here. Yeah. And then I'll join them there. That's happening hopefully a lot today. Okay, so I have that, and then I'll click on finish. And then with that, I can select this bar, go to the comments, to the properties, ensure the partition is correct. In the layout rule, ensure that it is maximum spacing. Let's have a spacing of 200 mm. And then in the comments, let's use top one for this one. And then we can click on OK. Then the next bit now is to model the secondary bars, the bottom twos and the top ones. So to model those bars, we go to Rebar, and then we are going to use expand to host, and we are going to use shape 00 or 01. Okay. And then for any bars that we said we would, in layman's language, that we would be viewing them as dots, or they'll be running perpendicular to the cover, we select perpendicular to cover, and then change the layout rule to maximum spacing and have a spacing of 200 mm. Okay. And then in the partition them correctly as the stairs. And then in the comments, do the necessary. So we are going to start with bottom two. And then after that, you are going to see these, these dots. So just bring them near to your bar and left click. And you're going to have your bars model there. Then do the same for the top bars. Go to Rebar, select shape 00. In the partition, ensure that it is stairs. Comments, let's have top two. And then in the layout rule, maximum spacing, and the spacing is what we need. And then bring them close here or near your bar and place them. And then for this one, we do not need them near, along this part where we do not have any top bar. So we're going to select it and drag it backwards. Okay, so we're going to select it and drag it backwards. And then we can have such a detail there. And then those will be our top one bars for this particular section here. Okay, those will be our top two bars for this particular section over here. And then for this other section over here, we do the same. We go to Rebar, we select shape 00, and then we place them at this junction here. Sorry, we place them at this junction there, and we should be good to go. Then after you do that, select them and drag them, so that they span along where they are actually needed. Yeah, so you have that, and then with the bar still selected, change the comments to top two, and you are good to go. So that's how you do it. Then the other thing would be now to model, to model the bars that are going to be in the, how do you call this? That are going to be in the landing. So for that one, it's going to be easy. You just go to Rebar, and then you click on sketch, select your staircase. And then at this point, we are going to have a bar here. This one can be straight. So we're going to select a bar here and bring it to that section there. And then have it as there as well. And then click on finish. And then for that one, select it. Go to the properties, ensure the partition is correct. In the layout rule, have maximum spacing and have 200. And then in the comments, let's have this as top one, and we'll be good to go. Okay, so I'll model the rest of the bars after I model the bars for the other run, so that it makes a bit more sense. So now we want to model bars for this top run. It's going to follow the same procedure, but now it needs to go into this other section. So if I try to select Rebar, sketch, and selected my staircase, I will not be able to draw, I will not be able to draw these bars in this, in this run here. So to model bars in this run, you just go to the other section, you select Rebar, and then you select sketch, and you select your staircase, and then you start modeling. So for this one, we are going to start from here. So you select this bar, and you model the bottom part of it, and then it's going to go, along the bottom part of this staircase. And remember, the bottom part of the bottom rebar has to go to the top of the slab, and then in the slab, ensure it extends up to the support, and then you can curtail it there. And then after you have that, use trim extend to corner to join them, or make your work easier in joining them. And then after that, just click on finish, and you should be good to go. So you can now select this bar, go to the properties tab, ensure that it has been partitioned correctly, stairs, and then in the layout rule, have maximum spacing, and then in the spacing, have 200 mm. And then in the comments, change the comments to bottom one and click on apply. Okay. And then you have your bottom one bar over there. So you're going to select rebar again, use sketch and sketch the other rebar. So you're going to have a small top bar here. So you're going to select to draw just a small top bar there. Okay. And then this top bar will also go to, it will go to this lower run as well. So it's going to extend into this lower run as well. And you're going to join them in such a manner. And then click on finish. And then after you have that, go to the properties tab, select it, go to the properties tab, change the partition to stairs, the layout rule to maximum spacing, and a spacing of 200 mm. And then in the comments, change the comments to top one, change the comments to top one for this, and then click outside, and you're good to go. So the other bar that we need is the top bar here, top one bar here, and that should be easy to do. So you just go to structure, rebar, and then you select sketch, and you select your staircase. And then with that, you just select your staircase. Okay, you draw your first part there, and then you draw the other one in a similar manner. And then after that, you just join them, and you click on finish. Okay, and then after you have that, you can now go to rebar and model the bottom bars. So the bottom two bars of the secondary bars. So you select shape 00 or 01. You go into the properties tab, you ensure the diameter is correct. So the layout rule is correct, and then the comments. So the comments are bottom two, and then or should be bottom two, and then model or place them there. Okay. And then for the top one or for the top two bars, you do the same thing, rebars, shape 00, and then the properties tab, stairs, layout rule, maximum spacing, and then for the comments, now we should have top two. And then you zoom in, sometimes it's a bit tricky, so you can just place them at such a point, and then drag them backwards. Okay, drag them backwards. And then once you have them here, you can now move them. You can press shift so that you can move them with the same angle there. Okay. Yeah, so I think that's good. Then after that, now we can do these top two bars here. We go to structure, rebar, shape 00. Ensure that the placement orientation is perpendicular to cover. And then in the partition stairs, in the layout rule maximum spacing. And then in the comments, let's have top two. Okay, and then model your bars are right there. Okay, and then after you have that, select them and now drag them to this portion here. Okay, now you have that, and you have modeled all your bars, at least for the first run. Okay, and then after you've modeled your bars for the first run, you can close this one, and then we are going to focus on these. We are going to focus on this section that has the thickener. So after you've modeled all the bars for both runs, we are going to focus on this thickener. if certain bars are not visible, just go to the first floor, select these view and extend them. So select them and extend them just to ensure that both bars or all the bars are visible. Okay, and then once they appear, you are good to go. So what you're going to do at this point, we are going to copy these bars to the other floors instead of us remodeling them. So we are going to select one of them. We are going to right click, and then we are going to select all rebar in host. Okay, select all the bars in this staircase. You left click on one, right click, and then you select all rebar in host. And then after you've done that, it now becomes easier to copy. After they're highlighted, just click on copy and check constraint. Okay, and check constraint so that you are able to move, along the Z axis. And then after that, click on this top part of the grid and then copy them vertically upwards to this other top part of the grid where it meets the slab. And then after you have that, you're good to go. So the only edit you need to make at this point is to select this and delete the starter bars because we do not need them in this particular view. Please ensure you are muted. Okay. And then for this one, we could just select it and move it upwards so that we observe the correct cover. Okay, so we have that. So the next thing that we're going to do is to select this bar and edit its shape. So we're going to select it, go to edit sketch, and then we are going to delete this line here. And we are going to draw another line here. So we're going to draw a line here. Sorry. I'll continue sketching. And I'm going to extend it in such a manner. Okay, and then after I do that, I can click on finish and I'll be good to go. So the next one should be this run here. So I'm going to go to structure, rebar, and then for the top bar, sorry, I'm going to go to structure, rebar, and then sketch, and I'm going to select this other run. And then I'm going to draw, the top one bar there and drag it in this section as well. And then I'll select them and join them and click on finish. And then with that, select this bar. This one does not have the comments. So we have the comments as top one. Okay. For this one, ensure the comments are top one. And then for this one, ensure the comments are bottom one as well. And then with that, we can now copy these other bars to the other floors. So again, we're going to try and make this easy. So we are going to highlight everything here. Okay, so I'm going to highlight from left to right, highlight everything in this section over here to ensure I select everything. And then I'll go to filter, I'll check none and select structural rebar. Okay, and then I click on apply and okay. And then you'll come here and just have a look. Ensure you do not copy the bars that are going into the lower run. All the bars that you've selected are going to be going into the upper run. If, for instance, you've selected a bar, say, for example, you've selected this bar that is going to the lower run and say this one. If you find they have been highlighted, just zoom in, press shift and left click on them on it. Then go to the other one, press shift and left click on it. And then after you're satisfied, all these bars are going to the upper level. You select copy, and then we are going to use this top edge of the slab, where this top edge of the slab, meets with this grid. We're going to use it as our base point. So we're going to use left click on it, and then copy it to the other floors. So you copy it from that floor, then to the next one. You ensure you just click on that similar point on the next structure, and then to the next one, and then to the next one. Okay. And then after you have that, we'll now have modeled all the rebars for your staircase. All right, so it's that easy to do. And then for the annotation, it now becomes even easier for you now because you're quite adept with them. So you just go to annotate. And then for the section, for all the sections we've been using tag by category. So you select the tag by category, you place one, and then you just select it and select the quantity type spacing that you've been using. And now you can tag them. So select this one and then go to edit type. If it doesn't have an arrow, please provide an arrow if you would like to have one. And then you can click on apply and okay, and you'll have your arrow there. And then you can proceed to tag all of the bars that you have modeled. Okay, so it's that easy to do. So I will require you to to tag the entire section. So for you, you're going to be tagging the entire section. You're going to tag from from the bottom to the top, and then you can have that in your detail. Okay, so at this point, you just click on the bar and you tag it. And then for this top one bar, don't have it here. It's going to create a bit of confusion. So for this top one bar that is going into the landing, please tag it from this view over here so that it makes a bit of sense. Okay, so that whoever sees it can be able to now understand what is happening. Okay, and then continue to tag the others. Okay, so basically that's how you do it. Okay, that's how easy it is to do. All right, and then you can have your details really well. So ensure you arrange these tags in a really in a really orderly manner so that all your details can be easily seen, or they can be read easily, right? And then after you've done this, the next detail that you would need to show would be the staircase plan detail. So you've probably seen those detailings that show these staircase rebars being detailed in the plan view. So to do that in Revit is easy. Just as you did for the footings, you're going to go to the structural plan. And then for this one, I'll recommend you work in the first floor. And that the reason I'm recommending the first floor is because you're going to be able to see the starter bars. If you do it in the other floors, you're not going to be in a position to view these starter bars in that plan view. So I'll recommend you go to the plan view. And then at this point, just go to view, click on callouts, create a callout, and create a callout along this section. Okay. And then after you do that, go to your structural plans. You're going to have the callout here, and you're going to rename it. So you can call it stair plan detail, and you can click outside. Okay. And then after you do that, just left click on it twice, and then we can come here and now clean this up. All right, so let's clean this up. So the first thing that you're going to do is you're going to hide these, you're going to hide the section views by category. We do not need any of them. And then for the scale, we can use 1:50 for this. And then for the slab itself, we can also hide it in view. We do not need it. So we can hide it in view by category. And then for the beams, so you're going to select the beams that we can hide. So select them. Select these other beams that are going in this different direction, and then right click to hide them in view by elements. Okay. And then for the CAD file, if yours is visible, just left click on it, right click, and hide it in view by elements as well. And then you have a bit of a cleaner detail. And then for all the grids that you do not need, just select them and hide them in view. And then you'll have such a detail. And then at this point, you're going to notice one thing. You cannot see all the bars. And the reason you cannot see all the bars is because this view usually they have some settings. So each view in Revit has a setting that alters or that defines the depth up to which you can see. So for example, in this first floor, by default, Revit has assigned this floor a certain settings to ensure that you cannot see the ground floor or even the foundation level. You can imagine how confusing that would be if you're in your first floor and you can see your ground floor elements. That would be a bit confusing, but it also gives you the ability, okay? Revit also allows you to change those settings so that in case you find yourself in a scenario where you'd want to see elements from a lower floor, in this upper floor, you can be able to do that. And that is what we are going to do in this stair plan. So this stair plan is in the first floor, okay? And at this point, we want to see the rebars in the ground floor as well. Okay. So to do that, the rebars we want to see are these lower rebars. We cannot see them in this plan here. You can see you cannot see them. So to activate that, we are going to ensure first you've not selected anything. Press escape a couple of times to ensure that you are not in any command. Then once you are sure you are not in any command, go to the properties tab on your left, scroll down to extents, and then under extents, you have the view range, okay? Under extents, you have the view range, and then you'll click on edit. And then once you click on edit, you are going to change this parameter, the bottom and the view depth. So you're going to change the bottom of this view to the ground floor. All right. So so that the top level is the first floor, and then the bottom level is the ground floor. And then for the offsets, we are going to have let's enter an offset of about negative 300. And then just click outside and then go to the view depth and select the ground floor as well. So here is a small caveat for you, or something that you should note. The view depth should always be deeper than this level here, okay? So you cannot have this one as the first floor and this one as the ground floor. So this one should be deeper or this one should be lower than the bottom. So the view depth, have it as the ground floor. And then for the offset, let it go lower by negative 400 so that it's just slightly lower, okay? And then click on apply and okay. And then you can see that. So at this point, we can see the beams from the ground floor. So I'll select them and I will hide them. Okay. And then once you have this, now it becomes easier to do because now all you need to do at this point is to change the presentation. So you're going to be selecting one set at a time. You select a set, you go to presentation, and you just alter how they are presented so that you remain with one bar. Then you select, you go to these one here, select one of them, go to presentation, select none, and select the bar there. Then go to this presentation here, click on tab. Okay. Select a bar here, go to presentation, select none, and then you can select one and then click there. And then select a bar here, go to presentation, select none, select one of them, and click on finish. And then do the same here. You have bars here, select one of them, go to presentation, select none, and then click on finish. And then go to this other set, select one of the sets, go to presentation, select none, and then go select one and then finish. Then select the other sets, click on presentation, select none, select another one, and you click on finish. And then at this point, select another set, okay? Go to presentation, select none, and then you select one and you click on finish, okay? Then you do this throughout, you select another bar, you select none, and you select finish, okay? And then you select one bar here, you go to presentation, you select none, and you just click on finish, okay? So at this point, I want to see something. Before I make changes to this one, this does not make sense here. So I'll select them, and then I'll go to the section view, and be able to see them. So I want to see the bars from this level going downwards. I don't want to have this bar here because it has already been represented by this bar here. So if I have this bar in this view, it means that I will be having a bar that has been double represented. Okay, so for this one, just select this bar, right click and hide it in view by elements. And then you can go to this section. Let's select this bar here. Okay, let's select these bars. Sometimes they are visible. Select them. These bars that are going, from the first floor to this landing. Select them in this view. Then go to the plan detail. Right click and hide them by elements. Okay, and then after you've done that, you can select these bars. Go to presentation. Select none, and select one, and then click on finish. And with that, you have a good detail. So for this one, I can change it, how it has been represented so that I can have a bit of space between those two bars. And now I am good to go. And then after you do this, just annotate them. Click on annotate, multi-ribbon tag, and you basically annotate them in such, Okay, so this bar, the reason it's not doing that, it's because it is a single bar. So you have to select it, go to layout rule, change the spacing to maximum, and then enter the spacing, and then check if it has a comment. If it does not have any comments and you are not sure which bar it is, go to the section view. From this point, you can be able to decide, or you can be able to tell which bar that is. So for this one, we can now tell from this view that it's a top one bar. Click on apply and then go back to your detail view. And then you can select it, click on presentation, select none, and select the others. Okay, and then you can now select the multi-ribbon tag and place this one appropriately. And then do the same for this one, place them there. Okay, for this one as well. Okay, so this one I have not changed its presentation. So I select none, and then I select one of them and I click on finish. And then after I do that, I can now go to multi-ribbon tag and tag it. So let me look for a position to place it. Okay, and I have that. And then I can place this one and I will have it there. And then I can now, retag this one and tag this one as well. So I can tag this one as well on this direction. Tag this one. Okay, and then you can always select these bars, ensure that they are arranged in a manner that is a bit appealing so that your work looks neater. Okay. Okay, so you can have that and then go to this other side and tag them as well. Okay, so you can have that. Okay, so I've created this tag twice. So I'll delete one of them. And for this one, I can place it around here. And then all now I need to do is tag these ones and I'll be good to go. So basically that's how you can easily create this detail. So if you've used CAD, I know this could be a bit of a task, but with Revit, at least it's a bit easier because all you need to do is create a view, get to see how your bars have been represented, and then annotate them. And then for the grids, as usual, I always try and bring them closer to the model so that they do not occupy a lot of space when we go to the paper space. Okay, select them, select these ones, and then bring them closer. Okay, for this one, bring them closer, but ensure that they do not go beyond the tags. Do that as well, and bring this close. And then you can click outside. And then with that, I think you should be good to go. Okay, so that's how you annotate a staircase plan detail. All right, so that's how you do the detailing or you model the rebars for the staircase. And then the other thing that I'd like to show you is something that we have done before. So the staircase that we have actually annotated, let me select it here. Okay, I will go to, to the view tab here. And then I'll highlight, let me see. I'll highlight everything. I'll go to filter, check none, then I'll check structural rebar only, click on apply. And then in the visibility graphics, I can have this as view unobscured. And then you can be able to see how your rebars are arranged even before you go to site. So if there is something that is clashing with anything else, you can be able to tell that early enough. Okay. And then you can even hide the staircase in this view. You can be able to hide the staircase in this view and it'll be good to go. Okay, so that's how we generally model those rebars here. Okay, so I'll go to the next part. And the next part now we're going to be modeling, the hollow pot slab. You're going to do it in two steps, or you're going to do it in two steps. First, you're going to create the ribs inside Revit. And then we are going to use the family creation tools to create the hollow pot slabs. Okay. So I want you to take a look at the image I sent or we sent in the in the channel. So this is the type of hollow pot that we want to create, and they are usually used to fill the space between the ribs. So if you design as you design your slabs, or as you design any RC member, you know that below the critical axis, we do not need any concrete there for compression, right? So if we do not need the concrete for compression, the idea is we can replace it with cheaper and lighter materials to make our design more efficient. So in slabs, there are a lot of ways in which you can do this. You can use the waffle slabs. I've seen others use there are some balls I've forgotten how they are called. I'm sure even probably Rashid from Pakistan. I'm sure you have something that you use just to fill the slab when you do not need that extra concrete depth. Okay, and it has its various advantages. One, it is majorly used in schools because the air voids between the pods themselves, they usually act as some sound barrier. So if other students are up there making their own noise, the ones below in the lower classes, they cannot get they will not get to feel that noise or get their lessons interfered with. Then the other one, it's cheap, it is lighter, it is way lighter than concrete. So if it is lighter, it may lead to uh, you reducing or decreasing the dead loads of your structure. And then if the dead loads are significantly reduced, it means that you're going to be having smaller sections for your beams. You're going to be using less steel, and also your foundations are going to be smaller and also more economical. Okay. And then it is majorly used where you have longer spans, where you'd want to increase you'd also want to increase the depth of the slab without increasing its width. So it is used in such a manner. Okay. So I will go to Revit, and you are going to do that first. So we are going to do the slab in the fifth floor or the fourth floor. Let me see. Okay, just do it in the floor where you've not modeled your beams, where you do not model the rebar for your beams. So do it in that level. And then at this point, you can select all the bars here. So select one of them, right click, then select all instances visible in view, and then just right click and hide them in view so that we have clean detail. And then after you have this, go to the visual style, change it to shaded so that you can be able to see the slab. And then once you are here now, we can now be able to create the pots. So now since the entire slab has been covered by concrete, what we can do is create spaces for the areas where we want to model those hollow pots. So to do that, we are going to go to structure, and we are going to go shafts. So we're going to create a shaft opening. So click on opening over here on the rectangle over here, and you can basically draw a rectangle here to create the shaft opening, and then click on finish. Okay, so that is one way in which you can do it. Alternatively, the other way in which you can create this opening is by selecting the slab itself, going to edit boundary. Then once you go to edit boundary, you can select the areas where you do not want the concrete to be. So for example, these large spans, we are going to use you're going to use the pick lens to pick the inner edges of the beam, and then use the trim extend to corner to join them. And then click on finish. So that's another way in which you can create an opening or space in your slab for the other systems. So I'll repeat that. So to do this, you're going to select the slab boundary, and then after you select it, you go to edit boundary, and then for these large spans, you can select the inner edges of their beams, and then use the trim extend to corner to ensure that these boundaries are continuous, and then you can click on finish. And then now that you're used to that, you don't have to click on finish every time. You can select the slab, go to edit boundary, and then create as many openings as you need. Okay, create as many openings as you need. So to save on time, you can create as many openings as you need, and then now you click on finish. So let's do that. We create all the openings that we are going to need. And then we go to trim extend to corner, and we join them. And then we do the same here. We select these, and these, and then trim extend to corner. And then this portion here. So trim extend to corner. And then we are going to use the trim extend to corner here to close this loop. Okay, now we have that. Okay, so after we have that, we can click on finish, and just click on attach, and you're good to go. So if you've not created an opening for the staircase as well, you can use any of the methods that we know at this point to create that opening. But this region here where you have your lift core should have an opening to allow the lift core to go up and down. So as it has been modeled this way, this is quite wrong. So you can be able to just correct it. Okay. So after we have modeled these, we've created the space, now we are going to do the modeling. So we are going to start with creating the ribs, and the ribs act as the supports for your hollow pots. So basically, this is what you're going to be having. So these are the ribs, and then the hollow pots are going to fill the space between these two ribs. Okay, just as you saw in the video, you saw the ribs being placed, and then the ribbers were laying in such a manner. So we are going to share the video so that you can rewatch them, get a better understanding of what you are doing, so that you can be able to, model this better. So we are now going to start with creating these ribs, and then we are going to use a new tool called the rib system. So we are interested in creating many beams running at the same, running at at a given interval. So we do not need to model them one by one. That would be tedious. So we're going to use the beam system to make that much easier for us. But before we do that, I'd like to bring something to your attention at this point here. So this is something that you should note. Let's see. Okay, so this is what we have. So you can see the ribbed and hollow block floors, they behave the same way structurally. Okay. So the only difference is that in the ribbed floor, you do not have these blocks here to fill the space. And the advantage of having this hollow block floor over the ribbed floor is it is easier to get the props for or the props that we use during casting for this slab here. So for this one to cast would be a bit expensive, but for this one we've used the local materials available. So that's one of the advantages of having these blocks over here. Okay. And then they are going to be supported by these beams here. Okay. And then these beams are going to be placed at a given interval. All right, so this is the thing I wanted to bring to your attention. So let me see if I can highlight this. Where? Okay, so here it is. So the thickness of the flange should not be less than 40 millimeter or 1/10 of the clear distance between the ribs. Okay, whichever is greater. So we are being told that the thickness of this slab or the thickness from the top of this pot to the top of the slab should not be less than 40 mm or 1/10 of the distance of the clear distance between the ribs. So the clear distance is this portion here where the pot will be occupying. So if we have a pot of say 390 millimeters, such as the one we have there, you can see that the minimum distance that we could actually have is 40 mm because it's greater than 390 divided by 10. And then for the ribs without the blocks, the depth should be 50 millimeters at least. Okay, but I think here in Kenya the practice is usually have this depth at 60 to 75 mm, and then you incorporate these ribs depending on your design. Okay, and then the other one is the ribs should be placed no further than 1.5 millimeters, and their depth should not be greater than four times their width. Okay, so the spacing between, as you do your design, the spacing between the ribs should not be greater than 1.5 meters. Okay, the spacing between the ribs should not be greater than 1.5 meters. And then also the distance from the lower edge of the flange to this point here, or the depth of this ribbing here, should not be the depth below the flange should not be greater than four times their width. Okay, so this distance, please ensure you're muted. So this distance here, okay, so this distance below the flange here should not be greater than four times the thickness of this flange here. All right. I think so. With that in mind, I think we can now go and model our ribs. So we are going to start with these ribs. Then we are going to place our hollow block, our pots. Okay. So to do this, we are going to use the rib system. So we are going to select the ribs, and then as you select the ribs, you're going to have this section here. So I forgot one thing. We need to create the beam cross section. Okay, so you need to create a beam cross section first. So you're going to go to beam. Your first stop to creating the hollow pot system is to go to the beams. And then once you go to the beams, you're going to go to edit type, and you're going to create a rib system. So you're going to click on duplicate, and then you're going to create a new family or a new type. So let's call it ribs, and then click on OK. Let's enter their thickness. So let's have 125, the width, and then for the depth, we could have 200 mm, okay? Or we could have, let's enter 215, or 200 will be sufficient for this case, and then click on OK. And then in the breadth, have this as 125 mm, and then in the height, let's have 200 mm, and then click on Apply and OK. And you have that family created. And then with this family created, you can now go to the rib system. And then at this point, immediately you click on the rib system, your first stop will be to set the settings here. Okay, so our main interest is in the pattern. So we want to have a fixed rule. The layout rule for this one, you're going to use a fixed distance. Okay, the fixed distance ensures that the fixed distance ensures that the distance we enter for the spacing between our ribs is going to be observed at all times. So we are going to use the fixed distance. And then for the fixed spacing, this is where I will need you to work with me. Okay. So you can see that the thickness or the length of this, the width of this block is 390 mm. Okay, I hope you can follow that. The thickness of the thickness of this particular pot is 390 mm. And then after you've taken note of that, note that that particular pot is going to come to this section here. So the section from this edge of these, from the edge of these, uh, rib to the edge of this other rib is going to be 390 mm. And then after that, since the spacing is usually center to center, we need to add half the width of this rib and then half the width of this rib. So half plus half generally means that you are going to enter the width of one rib. So you're going to go to Revit, and then in this point here, in the fixed spacing, you can enter an equal sign. So say enter 390, the width of that rib, then click on the addition sign, and then enter the 125, and then press enter, and you have that distance. And then for the justification, ensure that it is center to center, and the beam, and then in the beam type, this is where you select the cross section we created. So select the cross section, ribs 125 by 200, and you should be good to go. And then as you model this, you should ensure that the ribs run along the shortest span. Okay, the ribs should run along the shortest span. So as you model them, ensure they run along the shortest span. Okay, so you can use either the automatic system. So if you use the automatic system, all you need to do is place your cursor in this section here, and then as you place it, it's going to draw those dotted lines. And then if you are satisfied with the direction along which they are running, you can place them. So for this one, they're running downwards, which is along the short span. So I'm going to left click and place them. And now if I try and measure the distance between these two ribs, you can see I have sufficient space to model or to enter my pots. Okay, so I'm going to redemonstrate that. So you go to beam system, and then our interest is in the pattern. So we use layout rule, and then the layout rule we use fixed distance. The spacing should be centered, should be 15, 15, 15. And how we got this 15, 15 is the thickness or the width of that particular hollow pot, and then you add the 125 millimeters. Then you click on enter, and then after that you just go to justification, ensure it is center, and then in the beam type you ensure that it's a ribs that you created. And then with that, you can now go and sketch your rib system. So you can either use automatic or beam system. So sketch beam system, you need to sketch the boundary of your beam, of your rib. Okay. So you can sketch it as you did earlier. Okay, you can sketch the boundary and then use the trim extend to corner. And then use the trim extend to corner. And then if you choose the sketch boundary, you have to enter the beam direction. We said it has to be along, the beams have to lie along the short span. So this beam, this direction here, this symbol here shows you the direction. So at the moment, Revit is going to model them running this way. So to change this, you just go to beam direction, use peak lines, and you select the short span, and then you click on finish. Okay, so it's not continuous on this end. So I just click on finish, and you do that, and you click on finish. So I'll select one of these tags, select all instances visible in view, and delete them. Okay, so you have that. So I'll do that one more time. So for this one, I recommend you use the automatic beam system. It's much faster. So for the pattern, it remains the same. And then you just come to this section here. You just move around with your cursor. Once it appears, press the space. Okay, just move it around. Okay, move around the supports and then just place it there. Okay. And then let's do the final one here. Move it along, move along your cursor along the beams and then click there. Okay. Do that there and that there. And you should be good to go. Then now after you have this, the next part is going to be creating the holopod slab itself. Okay. So you have to note that Revit does not come with these pods. So you will have to create a new family for yourself. Okay. Creating them is generally easy, only that it would need you to, to introduce you to a new environment of Revit that we have not done before. Okay. So we are going to go to File. And then once you go to File, we are going to go to New. And then we are going to click on Family. Okay. And then once you click on Family, this new family pop-up is going to appear and it's asking you to select a template file. So you're going to click on this drop down and then go to Family Templates and then select English. And then once you select English, scroll down and you're going to select Metric Generic Model. Okay, you're going to scroll down and select Metric Generic Model. All right. So don't be worried about these templates. Just as the families appear in different folders. So any family that you would need to create in Revit usually comes with its own template. So if you don't create a door, if you don't create a column, if you don't create a beam or a furniture, you're going to have a given template to assist you or make that easy for you. So for now, to create the pods, we are going to use the metric generic model. So you left click on metric generic model and click on open. And once you click on open, you're going to go into this environment that you're going to notice that we've not been here before. So you can notice the contextual ribbon looks a bit different. It has a few elements, and these are what you're going to be using to model the board. So at this point, I don't want you to focus on the other elements. I only want you to focus on what you're going to do. Just follow my steps. Don't worry about the rest. You are probably going to cover them later on or in an advanced course. So for now, we are only going to be focusing on creating this one family. All right. So to create this family, you're going to create it by extrusion. And by extrusion, we basically create that model, or we just create that 3D element. We just extrude it. Basically, it just means extrude. All right. So we're going to use extrusion. And the face that we are going to be using is this front face. Okay. We are going to be using this front face to create we're going to use this front face to create our family. Okay. We are going to use this front face to create our family. So we're going to go to Revit. And then once you go to Revit, in the project browser on my left, please let me know we are together. Please type a one if you are together. Let me know you are together. I don't want to go alone. Nice. I can see you are together. So I'll proceed. And then please ensure you are muted. Okay, so I'll proceed. So we are interested in using this front face. Okay, we are interested in using this front face to create our model. So we are going to go to Revit, and then in the project browser, you are going to scroll down to elevations, and you are going to use front. So you're going to left click on front twice to open it. And then at this point, after you've opened the front face, you're going to draw uh, reference planes. You're going to use reference planes as guides, okay? So they are generally used to create just a reference plane for you to create your families in Revit, okay? And then these reference planes, you're going to be creating them. Let me open my image. You're going to be creating them along these boundaries. So you're going to create a reference plane for this, for this boundary here, for this boundary here, for this boundary here, for this boundary here, and then for these boundaries as well. Okay. So just think of it as it's as if we are now going to be detailing this in 2D, and then we extrude it to create a 3D family. Okay. So we are going to go to Revit. We are going to start with the reference plane. So you are going to select the reference plane, and then select line and draw the first reference plane. Sorry, not the reference plane. You go to create and you select the reference plane. Is it that? Yeah, you select the reference plane. Okay, please don't select the reference line. Select the reference plane. And then after you've selected the reference plane, just draw a line arbitrarily. Don't focus on the distance between them. Draw the one line arbitrarily and then extend it there. And then after you've done that, go to this image. So we want to have this 25 mm first. The distance between this opening here and this opening here, right? So please follow me. Please follow me closely. So this will be the center of our pot. Okay, so this will be the center of our pot. This center here, in between these 25 mm. So this edge here and this edge here are equidistant from the center, meaning they are 12.5 mm from the center. So we are going to go to Revit, and then you are going to select one of these lines, and then in this distance here, just type 12.5 and press enter. Okay, then select this other distance and type 12.5 and press enter. And then you can probably zoom in to ensure that it's a bit visible. Okay, and then after you've done that, we go to the image itself again. So we have this 157.5. So we start with that. We go to Revit. You go to create, okay, and then reference plane, and then you just draw a line arbitrarily on this end, and then another one on this end as well. Okay, and then you select this one. You're going to have the dimension shown between this line here, this plane here, and this plane here. Left click on that dimension, enter the dimension you want, 157.5, and then press enter. Okay, do the same on this other side. Select it. In this dimension, enter what you need, 157.5, and press enter. And you're good to go. Then let's do the other one. So we go to create. Remember, you are using the reference plane. So you click on reference plane, and now you draw other lines on the outer sides, okay? On the outer sides. And then after you do that, select this one. No, you select the outer line. You select the outer line. Select this distance, and you enter the distance 25 and press enter. Then you select this outer one. You type the distance here and you press enter. And you have at least the outer edges formed. All right. Now we need to create the edges going upwards. So let's have a look at that. We go to our image. We have 25 mm, then 90 mm, and then 25 mm. All right, so let's do that. We go to create reference plane. Please remember reference plane. So reference plane, and then you draw a line arbitrarily. Then after you draw the first one, select it. enter the dimension 25, press enter. Go to create again, reference plane, draw another line arbitrarily, sorry, it has to be perpendicular. Please ensure it is perpendicular or straight. Reference plane, draw a line, select it, enter the distance 90, press enter. And then go to create again, reference line. And then I promise this is the last one. You just draw it there, and then you select the outer one, you enter 25 and you press enter, and then you click on escape. Okay, so we have these, we have a representation of these. I hope you can see that. I hope you can all see that. So we have at least a representation of this. So what we need to do is to now draw the extrusion, and then Revit is now going to do it in 3D. All right. So we go to the software, and then as we said, we are going to model this by extrusion. So we go to create, and then we left click on extrusion. And then at this point, after you click on extrusion, let me close that. After you click on extrusion, it behaves in the same way as modeling the slabs. All you need to do is draw the boundary. So we are going to start from the outer edge. Just draw a line. You can incline it at this point. I think most of the hollow pots I've seen in Kenya, we usually have this inclination here. So you can incline it at that point, incline this one there, and model it to the top, to the bottom one here, the bottom one there, and then use trim extend to corner. Okay, and then at this point, please don't close. If you close at this point, this is what is going to happen. If you go to 3D, you're going to have a solid block. Okay, so I had Rashid, you said you use solid concrete blocks. So if you need a solid concrete block, this is how you would create it. Okay, but for us now, okay, we are interested in having a hollow, a hollow block. Okay, so what you are going to do is I'm going to go to edit extrusion so that we can create the other boundary in here so that the concrete part remains the thickness only. Just as same principle as you have been using for the slabs, same principle as you have been using for the shafts, it just applies here. Okay, so I'm going to start with the peak lines, and then I'm going to use the offset of 25 mm, and then offset this particular edge, and then offset this particular edge as well. And then I can offset this one, this one, this one, and then I can change this to 0, and then pick this in a line, this in a line, and this one there. Okay, then I'll use trim extend to corner to ensure that it is a continuous loop. Remember, it's just the same principle, nothing new. Okay, and then after you have that, you'll notice that now you need to draw other lines here. So just draw them. Draw just 2 short lines, and then use the trim extend to corner to ensure that this line is now continuous, and it's a continuous loop. So let me do that. Okay, and then after you have this, after you have such a detail, just click on finish, and then you can now go to the 3D view, and you can see we have our pot. Okay, so that's how you create the family itself. All right, then now the other aspect we need to change is the depth. So you can see this is the front face. So the distance from this front face to the rear face is 190 mm. Okay, so we need to enter that. So we'll go to Revit. We are going to go to the front face that we were in. Select our pot. Okay, you can do it in the 3D view as well. Select your pot. And then after you select your pot, go to the constraints in the properties and change this extrusion end to 190. Ensure the extrusion start is 0 and the extrusion end is 190. Then click on apply and OK. So we have such a pot. Okay, so this is the first step of creating this family. Okay, so I'm going to save it. So let me save it. I'm going to save it somewhere, file. Let me go to save. Where can I save it? Let me save it to my desktop for now. So I could call it port one. I could enter the dimensions. So this is 390 by 140, I think, by 140 by 190. Okay. Let me see if I got that accurately. Yeah, the depth is 140. So I think I'm correct. So I click on save and I am good to go. Then now to load this, we are going to create another family that includes this. So so that this can be, more dynamic, instead of you having to go and model one port by one port by one port, I think that would be tedious. So to make your work a bit easier, we are going to create another family using this family here. Okay. So after you've saved it, go to File, then open, go to New. Okay. After you've saved it, go to File, go to New, and then click on New Family. Okay. And then at this point, you're going to click on this drop down. And then after you click on this drop down, go back to Family Templates and then English. So for this one, you're going to select a new family. You're going to use metric, generic, line-based. Okay. You're going to select the metric, generic, line-based. So you're going to try and make this a bit more dynamic. So we're going to select the metric generic line-based, and you're going to use it to create a nested family. So nested families in Revit are basically families that are a combination of two or more basic families. Okay. So we're going to create a nested family for our hollow pot slab or for our pots using these two families. Okay. So after you open this, probably I could close it and then I'll explain that. So you're going to create a nested family. To create a nested family, after you've saved this pot, you go to File, then you go to New. Okay. You create a new family. And then in the templates, you go back to English, Family Templates. Then ensure you select English. Ensure you go to metric generic line based. Okay. Make sure you go to metric generic line based and then click on open. And then after you click on this, now we can create the nested family that I'm talking about. So to do that, we need to first bring that family we created. We said our nested family has two or more basic families. So to bring that family, you go to Insert, and then you go to Load Family, and then you scroll to where you have that family saved. So I have mine in the desktop, and where is that? So here it is, the port 90, 390 by that. Then I'll select it and open it. And then after I open it, I'm now going to go to Create, and then I am going to go to Components, and that my port is there. So it has been oriented in this banner. Press space and click at that junction there and press escape. Okay. Then after you do this, this is the next step that you're going to make. You're going to select these. You're going to select these spots. Okay. You're going to select these spots, and then after you select these spots, we are going to use the array tool here. Okay. You're going to select this spot and then click on the array tool. And then after you click on the array tool, you're going to select these endpoints and click on this endpoint as well. So it's going to create an array of two ports. So the array, using the array tool is the one that is going to ensure that as you model your ports, they continue to replicate. Instead of you having to model one by one, all you need to do is you go to Revit, you draw a straight line, and then the ports are going to be modeled. And then after you've done that, just click outside and you have that. All right. So after we have this, we can do something extra. So Revit allows us to make our families a bit dynamic. And then what makes them dynamic are the properties that we usually change in the type properties, okay? So we can always create new ones, and I want us to create a new one that is going to assist us in the scheduling bit of this course, okay? So to create a new parameter, so let me show you. So these are the the properties that you usually see when we go to the type properties. So we can always add a new parameter. So to add a new one, so here we're only going to add one, keep it simple. We are going to select these pods that we use the array tool to create. And then you're going to zoom in and select this dimension that looks like a 2, okay? Left click on it. And then after you left click on it, go to the labeling panel over here. Go to the labeling panel over here and click on this create parameter. So this creates a parameter that changes in the Revit model, okay? And then it changes automatically. So you click on this parameter and then we name it. So let's call this number, a number of pods or blocks, whatever you prefer. And then in the type here, change it to instance. Change this to instance. Okay, here you just click on the name, enter number of blocks, and then here enter instance, and then you click on OK. And then after you've done that, you can go to the properties. Okay, see here in the properties, you are picking this option in the bottom right, family types. Okay, this option on the bottom right, family types, and then you left click on it. And then now we have a new instance created here. So we can also limit the length. So we are going to left click twice here and then highlight number of blocks and then use Control C to copy that name. Okay, you left click twice or even once, and then you highlight the number of blocks or the name you created. And then in the length, you just enter Control V, and then you multiply it. Okay, you multiply it by this length here. And then this length, just for avoidance of doubt, is this 190 mm here. Okay, so let me go back to the software so that we can finish this. So I type 190, click on apply, hence, okay. And then you can see it's now going to be updating automatically. Right. And then after you've done that, just save it, click on file, save. You're going to be prompted to save it somewhere. So I'll select this and then I'll add a new name here. Okay. So I'll just add number of port one, uh, number of port one or number of blocks, whichever suits you, and then click on save. Okay. Then after you've saved it, just load it into the project and close. So save it, load it to the project that you are using. So I'm using Paul Kipoich's work. So I'll just highlight it here, check this box, and then click on OK. And then I will not save my work. I'll go to the, I'll click on escape. I'll go to the floor plan that I was working in. Where was that? I was in the 4th floor. Okay. And then once I'm here, I'm going to go to architecture and then components, list the components, and then I have my family here. And then in the placements, use placement on plane because we are in a plan view. Okay, so placement on plane, and then you can select where to place it. So I'll start with this point here and then model them. And then you can see now the importance of creating the nested family. So I can now extend it up to there and have such a detail. And then after I've created one, so for example, for these ones that are similar, I can now easily copy these. Let me check constraint so that I can move straight. I can easily copy this to the other ports over there. Okay. Okay, so we have that, and that's how you do it. Okay, and it's that easy. Okay, and then for this section here, so I forgot to copy one here, I can select it entirely and then copy it from this point here to this point there. And then you're good to go. And then for this point here, I'll just go to architecture again, components, select the pods, and then model them going in this direction there. Okay, just ensure it's straight and click there. And then, sorry, I don't think that was very straight. Let me go to components, place a component and model it in this manner here. And click there. So at times there will be gaps. And the reason you have these gaps is because these pods are usually of a fixed length. So if they cannot fit in this distance, you're going to have this gap here. So don't worry about this. These gaps usually happen on site as well, and they're usually filled with concrete during casting. Okay. So what you can do is you can just move this from this point there so that you can have something similar on both ends. So you can do that and copy them to such a section there. And then after you're satisfied with that, for this one, you can now copy them. Let me use this point here and copy them to this view here, 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 okay, and this view. Okay, let me use this option here to be accurate. Okay, and then this is the beauty of doing this. So if you have such a detail, you can just create a section at this point and get to see how, this interacts with your, with your details. So you can be able to create that. Okay, so there's something missing. There's something missing. So what I want you to do after you've created some of them, you can right click, select one, right click, select all instances visible in view. And then in the offset, remember we need to, remember it is going to be below this slab here, okay? There's going to be a slab above the pods. So you can select all of them. And then in the constraint, offset from host, so you're going to enter an offset of, let's use a slab of 60 mm. So you're going to enter a flange of -60, press enter. And then click on apply. It's going to take a moment and then press escape. And then at this point, if you now go to this section, you can see they have moved. Okay, let me see. Let me see how this looks like. Okay, so I can just measure this. This is 80. So I delete the dimensions. I'll select them again, right click, select all instances visible in view. And then I'll add the -80 to the -160. So I'll have -140 and press enter. Then apply, and they should move to such a point there. Okay. Okay. And then I still think they should move lower. So I'll select them, right click again, select all instances visible in view. And then I will add another -60 and then click on apply, and we should be good to go. So with this, once we model the slab here, it will look a bit perfect. So we are going to go to our fourth floor. And then for this section here, you're going to go to structure. You're going to create a floor. We're going to create a new one. So we're going to edit type, duplicate it, and then we can call it 60 millimeter flange, and then click on OK. Go to edit type, change the thickness to 60 mm, and then press OK. Apply and OK. And then after you do this, select these. Which one are we making edits to? I hope it's this one. And then you can just draw this there and then click on finish. Then if you go to your view, you can now see you have a detail that makes more sense. Okay, so that's how you generally create these. That's how you generally create these families, and you can have them in your detail there, right? So I will share. I record a short video tomorrow, so that you can be able to do this at a slower space. So thank you for watching today's class, and see you in the feedback session, and then our Saturday session as well. Okay. So thank you
Well,
for watching. Hello.
I have a question.
Okay.
It's on the rib slab.
Okay.
Uh, is there a way to, let's say, okay, when you're okay, let's say the spacing of your slab,
Yeah.
it's not equidistance, or it's not equally divided per each slab. You will find in some instances at the
Yeah.
ends you'll find maybe a half of the slab, or like a half of the hollow pod can only fit
Yeah.
there. Is there a way of making it dynamic such that if the spacing allows for half of the pod to fit, can that
Yeah.
be modeled when you're modeling? Can it be dynamic such that it can just pick half of the pod, then you, or do you need to make another family for that? Uh, the
You need
other
to,
the other
you need to
question.
make another family for that.
Okay. The other question, I think it's on the same on the same holopod. Uh, where do you change the, like, the when you want to specify the material properties, like the Newton
You,
per meter? Let's say you have the manufacturer's template, or the manufacturer's data sheet, and he has given
yeah.
you, this is the material properties, like the Newton per meter, all that, so that when you're going to do your loading, or especially for the dead loads, you have all that information given, so that it's easier to calculate when you're doing the analysis of the load of the dead loads.
Okay. So for uh if okay, so with regards to designing a slab that contains these pods, to decompose these loads, we usually do them manually. We do not do that with the software. If you look at software such as say software such as Robot, even Proto, I know they do not model the pods themselves. You need to decompose this load manually. So you can get to look at the manufacturer's detail, get to see how much each pot weighs, and then divide that between two pots or along the entire slab, and then design that slab using a rib slab.
Okay.
Okay, so you can change the properties here if you want to view them. So you can select, let me go to the 3D. You can select it here, go to material, select a material you want, but you cannot assign it structural properties. You cannot come here and say that uh, the stress that this material can handle is probably 6 newtons per millimeter squared. You cannot do that. Or the compressive strength of this material is such a value. You cannot do that. And I'd also like to think, I don't know, in my view, I don't think it's necessary, because as you design them, you are told that we usually assume that they play no role in the structural integrity of the slab. They are just there to reduce, they are
The volume.
generally there just to reduce the volume of concrete.
Okay. My last question, I think it's
Yeah.
on the same. Why have I forgotten it again? Forgotten. I think I've forgotten the question. Let me try and remember it in a minute. Go, go to that drawing. There was a question that I wanted to ask there. I don't know if I can see it.
Which drawing?
The
The book?
the P, the P, no the PD the Revit model.
Okay.
Hmm. Is it or is it or is it? Can't seem to see it. Oh, the one I wanted to ask on the columns. How, let's say you have done for one or two columns that are similar. How do you propagate that reinforcement to the rest? Let's say like the 500 by 200, and you want to replicate to the rest of the columns of the members. Is it similar as to how you are doing the footing?
Uh, with regards to propagating, I think it is something that, uh, you know, that requires a lot of care. Okay. So in this sense, so if you have the say the 200 by 500, the column one that we modeled rebar from, and you want to model the rebars for the other ones or propagate them, you can go to visibility graphics. Okay. I hope you can remember the filters we created, and then go to filters and then uncheck everything else. Okay. And remain with the column ones only. Click on apply. Okay. And then you can see we still have some elements that we modeled after we created the filters. So at this point here, you'd have to do this really, really carefully. Let me do this as shaded. Okay, so let me start with this bar here, this column here. I can select this column. Okay, these, or I can select, you know, can zoom in, select multiple columns. That they won't allow you to do that. So select one column at one level, okay, and then click on propagate rebar, and then you will align by face, and then you select the source face. So this is your source face, and then you go, you go, you know, you go propagating that to all the other rebars or to all the other columns. Okay, but
So you're
sometimes it does not work. It does not work quite quite well. So sometimes you just select one bar. Sorry, let me right click. Select select all instances. Say select all instances in hosts. Do I have that? Okay, I do not have that. So you can see sometimes it does not work very perfectly. So for example, if I select this column here and try to propagate the rebar, and as I propagate by face, you're going to notice that at this point, it does not propagate longitudinal, the longitudinal,
bars.
the longitudinal bars, especially if they have not been hosted correctly. So you can find that it's an issue with hosting. So if you can select this one and then uh, pick hosts, and then pick this column as the host, then press escape, then select this column, go to propagate rebar, and then you propagate by face, you select this face, and then you select this face, you're going to find that they are propagated. Okay, so it can be done, it can be easier, but it needs a bit of ingenuity as you do this.
Okay.
Okay, and then you have to be very careful So you can see like that one I've already messed. I've selected the wrong face, but you can always uh, left click on it to uncheck it and then proceed to do the same. So you'd have to do this, level by level. So for example, if you are doing uh, the the bottom ones, you can do that. But I think it's too tedious. If your interest is in scheduling, you can just have the schedule for one, for one column. And then from this view, you can tell for the column ones, I have this number of columns, and then multiply that amount of riba by that number. I think that's much easier.
Or you can manipulate the schedule.
Yeah, you can always manipulate the schedule. You can always add a calculated parameter.
Okay. 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 Okay.
Okay, so I think we've stayed here for 20 minutes. I've taken 20 minutes of your time, but I hope the session was really, really worth it. It's something that we've not done before, and I'm sure if you tried to look for a tutorial to take you through that, you would struggle a bit. So I hope you get to try that out so that whenever you need it in the future, you'll be in a position to do that. So thank you for attending today's session. Please work on the milestones that you're yet to work on and see you in the next one. So thank you and have a good night.